Hi, I'm Libby, and my project this semester focuses on classifying publicly traded companies into their respective industry groups. Today, I will be discussing my problem statement, my methods for gathering data, the classification algorithms that I used, some neural networks that I built, and then my takeaways and plans for future work if given more time. As a bit of background, I am highly interested in finance and will be pursuing that after graduation. And based on a project that I had in one of my courses this semester in my financial analysis and valuation class, I thought it would be interesting to utilize data science methods from this course to try to categorize various publicly traded companies into their respective industry groups. The industry groups that I chose were technology, pharmaceuticals, airlines, oil and gas, financial institutions, so banks, and telecommunication companies. I drew upon 17 metrics in the end to try to classify this data, and some examples of these include beta, which is a statistical measure of the correlation of one company to the stock market. So usually this is in relation to the S&P 500, as well as return on equity and profit margin. Both are measures related to the overall net income of a company. For data gathering, this was a bit of a challenge at first. It was difficult to find a central location that had current data and reliable data. In the end, I utilized Capital IQ, which is a trusted website that provides financial data, drawing upon 10Ks and other financial information from the SEC, as well as Yahoo Finance Google Sheets extension that I was able to download. The metrics that I chose were based on my outside financial knowledge from the class that I mentioned, as well as previous internships that I've had. I used this experience to inform my data gathering and trying to determine what metrics would be the most important and impactful in terms of differentiating between the various industry groups that I chose. I've included a screenshot of part of my data that I was pulling into Google Sheets. These are companies that I chose for the technology sector. So Apple, Google, Nvidia, Dell, Qualcomm, HP, and Microsoft. I pulled in their ticker and price, but did not use these two categories to classify the data. But as you can see here, I have the daily trading volume average, the PE ratio, earnings per share, and beta. And there were other metrics that continued beyond this that I used in my classification. My first classification attempt was based on principal component analysis and k-means clustering examples that we covered in class. My very first attempt yielded a 35% accuracy. However, I was not satisfied with this number, so I went back to try to fine-tune my classification. I changed things such as the number of singular values. However, this surprisingly actually did not have a really material difference on the classification accuracy. The key here was going back and normalizing the data. As seen before, some of my metrics are ratios and margins that are between 0 and 1. However, I have some other metrics that are closer to the thousands or millions, such as the daily trading volume. So this would mean that some metrics are being arbitrarily weighted higher than others. So normalizing the data was able to boost my accuracy by about 10%. Um, and this was actually the second best classification attempt that I found throughout my entire project. I then also looked at non-negative matrix factorization that we saw in homework 3. I was hopeful that this would provide numerical evidence of some metrics being more important than others when it comes to classifying data. However, I was not able to draw any strong conclusions. I ran into difficulty because the rank in my matrix was 17. However, I wanted to classify the companies into only 7 groups. So as you can see here, the norm of my approximation error was extremely high. I then turned to various classification algorithms based on class discussions and my own research. Out of all the ones I tested, the top 3 performers were the decision tree classifier, the XGBoost classifier, and the random forest classifier. The decision tree classifier yielded an accuracy of about 50%. This was the best I was able to do out of all my classification methods. I had improved this from my initial 35% accuracy when I went back and normalized the data. So once again, this was key. I then tried to build some neural networks to classify my data. My first attempt was not very successful. However, I went back and I changed things such as the activation functions as well as changing some of the layers. And I was able to get a final attempt of about 25% accuracy. I think my data set was probably too small for a neural network to be very effective. I also changed things such as the dropout rate to, again, boost this accuracy to about 25%. So overall, this project was a great way to implement the classification methods that we learned in class, and I learned how challenging it can be to fine-tune these models. If given more time, I would try to expand my data set because the one I used was relatively small for some of these classification algorithms. I would also consider using industries that were more differentiated from one another to maybe boost the accuracy there. Separating out companies based on their life cycle stage could also prove to be effective because early stage companies typically have very different financial profiles from late stage companies, even within the same industry. So, if given more time, I would start there. Thank you so much.